Hello everyone. In today's video, we will be talking about how this NCP tool helps us in documenting biochemical data. Before I proceed, I must again warn you guys that this tool is only helpful for us in calculations as well as documentation, in that the users are irreplaceable to conduct the critical thinking necessary to link all of the assessment data together. Now, let's have a look at how this tool helps us. In documenting biochemical data, it helps us in this tab right here, highlighted in green with a green line, called BC. It also does so in this tab right here, called BCGRH, short for biochemical graph. It has a lot of graph that has no data right now, which it actually relies on the data over here. There are three major sections in this BC tab. The first one is the part where we record all of our data. It would be following the NCP format. Next is below it, the documentation area that uses the data above to construct sentences. Below it also have few options to tweak your sentences around. Then to its right is a large reference section. There are three subsections in this one. The first one, highlighted in gray, is the main section, main reference section, which the value used here would be, the value input here would be used to evaluate the values that you recorded. This is the NCP reference for your own reference, and currently all of this reference here is also using the NCP reference. Next is the UNISA reference, also for your own reference, but if you would like to change the value here, you can also immediately copy the value over. There are also explanations on why a certain value is low or high, which you can view over here. Okay, let's try out this tab. Again, we'll be using the date that we have used in our CMHX, the 1st of October, being today's date. Make sure to include your patient's gender before proceeding to use the BC tab, because some of the values are actually relying on the gender. For instance, the HB here, the ALT, and the ALP here. If our gender are changed to female, the BC here will also be using give it a little while to load. It will also be using a female value, ALTF, ALPF. If you notice, the value here actually have also changed as well. So it's 35 to 105 for a female. If it's a male, it will be 40 to 129. Okay, let's try this out now. So this patient's fasting blood sugar, say it's 4 to 5.6 being the normal one. If it's less than 4, say 3.9, and it will be displayed in yellow, meaning that the value is actually below the normal range. Let's suppose the doctors have also done tests yesterday on the 30th of September, and his value is actually above 5.6, let's put it at a 6. It will be highlighted in green, signifying that this value is actually above the normal value. But if there is any value that is within or equal to the normal range, say 5.6 on the 29th of September, the cell will actually not be highlighted. So any value that's normal would not be highlighted. The highlights are only for lesser, highlighted using yellow, and higher, highlighting using red. Here is a spark line. It's basically a small representation of the trend of this specific biochemical data from 3.9 it rises to 6, drop to 5.6, and we can also put again 5.9, and you see the spotlight will change, dropping it even further. Okay, now let's say if we change the reference value that are being used here. Let's say the upper limit for the FBS is 6. If we put in 6 here, we should see that the 6 over here would no longer be highlighted in red, but instead remain white. And then, yeah, it is actually now remain white. But if we put this lower limit to a very high value, everything would actually become yellow. This is the same for every other biochemical parameters. So if we put 5.6, this should be red. For this BU, there are no data for BU. Let's try out sodium, 135 to 145. Putting it at 130, it should highlight in yellow, and so on and so forth. Then after you key in all of your value, you may also include some other values that is not included here. For instance, you have a biochemical data X, okay, and you found out the reference range for it is 5 to 9. You can put in the unit. You can choose not to put it in as well, but for now we'll just put it as millimole. And if you put it as 6, it should be normal. Put it as 4, it should be lower. Put it as 9, put it as 10, it should be higher. So there are exactly 10 rows here that can give you, that allows you to type in biochemical data that otherwise does not exist over at the above rows. Now let's scroll down to the documentation tab. If you see here, none of the sentences are being formed because we haven't chosen the thing that we actually want to include. So if we have a look, it says here high, total cholesterol 5.6, data X 10, low, FBS 3.9, sodium 130, total protein 65. These are only values for the 1st of October. So total cholesterol of the 1st of October is 5.6. 5.6 high. Fasting blood sugar for the 1st of October should be 3.9, low. So it's low. And the data X is also 10. Oh. You will take the earliest date. Okay, there is another problem with this biochemical data thing. I haven't been able to design it to display only a certain date. In fact, I myself isn't very sure which date is being used right here. It seems that every single row would be using the one with the earliest date, that exists within it. But in any case, it can help if you only key in one date, then it will only display that date. So if we choose high and low, both of these would actually be displayed in a dime and NCP. If we choose only high, only the high will be displayed. If we also choose decreasing data X is actually there's a general decreasing trend. That's what it actually detects. Okay, ignore everything over here. These are actually some of the remarks and some of the ideas that I like to work with, but didn't actually ended up working with. But I put there just to remind myself some of the ideas that I can potentially explore in the future, or you can explore in the future. Okay, next, nothing actually happens here. But one last thing I would like to share is how this data would actually translate into your NCP. So in your NCP, there is one table that documents all of the biochemical. And this is that table, and all of this data are actually being taken from this BC. So if I change this date to 27 and this value to 65, it would also be reflected over here, 27, 65, starting from the oldest date to the newest. At least that's how it's arranged in the NCP. But the highlight, of course, would not happen over here. At least I wasn't able to design it to do so. And there's also a note saying here that there is a data X whose value is 10 on the 29th of September 20. So any biochemical data that's included under the other section will be displayed in the notes. Okay, that's all. Again, there are three main sections: the parts where you put in your data, your references, and your documentation below. This is the main reference being used for evaluation. Lower is yellow, higher is red. If it's normal, it will remain as blank. The spark line would be just an easy way, but a way that I have found unreliable to evaluate the change in pattern. And there's also the other part, and finally there is a flaw where it will only display one date for the high and low for any of the data that you actually key in above. That's all for this video. I hope you find it helpful. Thank you.